Why do you only ever see one side of the moon? This is one of those questions you've heard so many times, you've stopped registering it. The moon is tidally locked. It rotates exactly once per orbit, so the same hemisphere always faces us. Sure, fine. But why is it so weird back there? The hemisphere we see from Earth has wide dark patches, the Maria, the seas. They're old volcanic flows from when the moon was geologically alive. The far side has basically none of that. Almost no Maria. Crust that averages about 20 kilometers thicker. Heavily, monotonously cratered. It looks like a completely different planet. For decades, nobody had a great explanation for the asymmetry. Then, in 2011, two planetary scientists published a paper that proposed something a little wild. The moon looks lopsided because Earth used to have two of them. You learned at some point in school that Earth has one moon. Always has, always will. That story is mostly right, but it's leaving out a couple billion years of weird middle chapters. The first thing to understand is where the current moon came from. Because if you've heard one cosmic origin story in your life, you've probably heard this one. The leading theory? About 4.5 billion years ago, when the solar system was a hot, violent chaos of forming planets, a Mars-sized body called Theia smashed into the proto-Earth. The impact vaporized a chunk of both bodies. The debris settled into orbit around the surviving combined planet. Within maybe 100 years, fast in cosmic terms, that debris ring clumped together into the moon. So far, this is the standard story. Here's where it gets weird. In 2011, two planetary scientists published a paper in the journal Nature, Jutzi and Erik Asphaug. They proposed a small but important amendment to the giant impact theory. What if, they said, the giant impact didn't form one moon? What if it formed two? A big one, the moon you know. A big one, the moon you know. And a smaller companion, about 1,000 to 1,200 kilometers across, only about 3% of the main moon's mass, sharing the same orbit. For context, Earth's actual current moon is about 3,475 kilometers across. The companion moon was roughly the width of Texas. This wouldn't be unusual physics. In planetary formation, leftover debris often clumps into multiple bodies before things settle. The companion moon would have parked itself at one of the Earth-Moon Trojan points, known as L4 or L5, gravitational sweet spots 60 degrees ahead of and behind the main moon's orbit. The physics says it could happily co-orbit there for tens of millions of years. So for a long stretch of early Earth history, possibly tens to hundreds of millions of years, anyone looking up from the surface would have seen two moons, which is, mathematically, the sky from every fantasy novel ever. But the companion moon's orbit was unstable. Over time, the gravitational dance between Earth, the Sun, and the big moon kicked the smaller one out of its safe spot, and the inevitable happened. The smaller moon hit the bigger moon. Slowly. This is the part that surprised everybody. Most planetary collisions are unbelievably violent. They explode. They vaporize. They throw up rings of molten rock. But this one was at relatively low speed, about 2.4 kilometers per second. Slow enough that the companion moon didn't explode on impact. It splatted. It piled itself onto the side of the big moon, like a slow geological tackle. And the side it stuck to is the side we never see. Suddenly the asymmetry makes sense. The far side is thicker because there's literally another moon's worth of material plastered onto it. The near side is thinner because nothing hit it. The near side, free of the extra layer, had a thinner crust. Magma could push through. That's why you see the dark Maria on the near side and not the far side. The model isn't proven. It's one of a few competing explanations for the lopsided moon. Other scientists argue that strong asymmetric tidal heating from early Earth might explain it without needing a second moon at all. But the Jutzi Asphaug splat model is currently one of the cleanest explanations for the data we actually see when we look at lunar rocks. NASA's Grail mission in 2012 mapped the moon's gravity field in detail. The data confirmed the asymmetry. The far side really is significantly thicker, on average, than the near side. The data are consistent with the two-moon splat model. But they're also consistent with a few other competing explanations, so Grail didn't single-handedly prove the Jutzi Asphaug theory. Whatever the exact mechanism, the data is unambiguous. Something happened to one side of the moon that did not happen to the other. Okay, so the second moon merged into the first one a long, long time ago. But here's the more entertaining question. What if it hadn't? What if Earth today still had two moons in the sky? The first thing that changes: tides. Earth's tides are caused mostly by the moon, with a smaller assist from the sun. Two moons would mean two tidal poles, usually working at slightly different times. Most of the time, the two tides would partially cancel each other out. Coastal water levels would be relatively calm. Beachgoers would be fine. But every once in a while, the two moons would line up on the same side of Earth, and then the tides would stack. We're talking about tides several times higher than normal, repeating on a complex schedule that depended on both moons' orbital periods. Coastal civilizations would have a very different relationship with the ocean. Cities like Venice, New Orleans, or Bangladesh wouldn't be marginally vulnerable to flooding. They'd be unbuildable. Life would have evolved anyway, probably, but entire branches of human culture would look fundamentally different. Coastal trade routes, fishing villages, port-based empires. The other thing two moons would do: mess with Earth's rotation. The moon's gravity slowly slows Earth's spin. That's why a day is now 24 hours, but was likely only about 5 or 6 hours long shortly after the moon formed. Two moons would slow it down even faster. Days would be longer, years would have fewer days in them. The seasons would feel different, none of which would kill us. Life is more flexible than we give it credit for. Here's the thing. The next time you go outside and look up at the moon, that bright, lopsided rock, you are looking at the result of the most violent geological event in our local sky. You're seeing the side of the moon that didn't get plastered. The clean half. The leftover original. The other side, the one you never see because the moon is tidally locked and forever shows us only one face, is the side that the smaller moon splatted into. The combined product. The Frankenstein face. For the first 100 million years of Earth's existence, anyone looking up would have seen two distinct objects in the sky. Then, in geological terms, one of those moons fell out of the sky in slow motion and took up residence on the back of the other one, where it's still sitting. You're looking at a graveyard. Geological. A cosmic merger frozen in stone for 4 billion years. The Earth you live on has, in a real sense, had two moons, for longer than you would believe. We're just lucky we don't have to deal with the schedule. Every culture that ever told a story about two moons in the sky, every fantasy novel, every sci-fi film, every legend of the time before the second moon fell, turns out to have been telling, accidentally, the actual first chapter of Earth's history. You just got the chapter where one of them goes away. The aliens were already here. The other moon was already here. Earth is older and weirder than your kindergarten teacher let on. Curious which counterintuitive psych effect we're cracking open Friday? Subscribe. It's about why you can't stop thinking about that thing.